OK， 准备开始喽。这什么东西啊？这不管了，这个怎么玩呢？干嘛呢？我看一下。人数的作业人数差一点。明天好像有个什么作业是吧？应该是一个什么作业的？这现在搞一下代码吧。代码我觉得是最重要，其他他妈都在浪费时间，真的。OK， 这下代码。这么卡呀！就这个是吧
？This is your LeetCode video solution to problem 383, ransom note. The problem states, given two strings, ransom note and magazine, return true if ransom note.
OK， 看一下说了什么东西。随机这个 notes 是吧？给两个，这不算一些杂志，放个去，假如他们可以背这个杂志那种关系。OK。
Note can be constructed by using the letters from magazine, and false otherwise. Each letter in magazine can only be used once in ransom note. How the constraints are, but the length of ransom note in magazine are between 1 and 100,000 inclusive, and that both consist only of lowercase letters. Let's look at how to approach this problem. If you've ever seen those movies where a robber writes a ransom note and uses cut-up letters from a magazine to hide their handwriting and remain anonymous, then you'll already be familiar with what this problem requires. We have the message we want to write in ransom note, and the letters we can take from magazine. We must determine if we have enough of each type of letter in the magazine to write our message in ransom note. A straightforward approach would be to simulate our process. That is, we go through each letter in ransom note and look for the letter we need in magazine. We can find the letter we need by checking each letter in magazine until we have the one we need. We then remove the letter from magazine and start looking for the next letter we need. If the letter can't be found in magazine, you return false. However, there is another thing to consider when removing letters from magazine. Strings are immutable, which means that they cannot be chained. So when we want to remove a letter from magazine, we must create a new string, copy over the remaining letters from magazine, then overwrite magazine with the new string. The time complexity is big O of n by n, where we go through n letters in ransom note, and for each letter, we look through up to m letters in magazine to find the letter we need. However, we also require an additional m steps to copy letters from magazine. We create a new string each time we take a character from magazine, giving us a complexity of big O of n by m plus n. This simplifies the big O of n by n. The space complexity is big O of n. This is because we must temporarily create a string to store a new copy of magazine with one less letter. Let's turn this into code. We'll start with a for loop that iterates over every letter in ransom mode. We'll access the corresponding character with the rwrap method, which is a constant time operation, as it's an index array access. A side note, some of you may consider using
等一下，去找一下我手机。哦，手机在身上。
for each loop with ransom mode to char array. However, this method allocates a new character array, which impacts our space complexity. However, this method can be more readable, so depending on the situation, you may use your good judgment to determine which option is best. Now we must iterate through the letters in magazine and look for a matching letter. What we want is the index of the matching letter in magazine, so we may use it to remove that letter when creating our copy of magazine. As you can see, we have our variable matching index, which has been initialized to a value of -1. If we find a matching letter in magazine, then we can save its index to matching index. However, if we go through magazine and find no matching letter, then matching index remains as -1. There is a convenient string method which does the exact same thing as this for loop. It's called index O, and it returns the index of the first letter that matches a provided letter, or -1 if no such letter can be found. We know then that if there is no matching letter in magazine or ransom mode, we may return false. Otherwise, we overwrite magazine with its copy. I'm going to make use of the substring method to make this copy. We provide the range of letters we want to copy from magazine. In this case, we want all the letters from the start of the string to just before the letter to remove. The first range is inclusive while the second is exclusive. Then we want to add all the remaining letters from after the letter to remove. If you want to copy every character until the end, you don't need to specify the end boundary. If we bomb through all of ransom mode, we may then return true.
什么鬼东西没网啊？太坑爹了吧！
The time complexity is big O of n by n. We iterate through the n letters in ransom mode, and for each, we iterate through up to n letters in magazine to find a matching character, as well as iterate over magazine to copy over all the letters we need to a new string. The space complexity is big O of n, as we create a copy of magazine whenever we remove a character. A hash map is a data structure with constant time access for any of its elements, specified by a key. In some programming languages, like Python, these may be known as dictionaries. When approaching problems where one needs to keep track of how frequently a certain element occurs, a hash map is the perfect data structure to use. Think of it like we've taken our magazine, cut out each letter, and put it in a pile with the same letter. This makes it much faster to find and see if we have a certain letter, rather than looking through magazine from the start for the letter we want. In our problem, all we need for magazine are the frequency of its letters, not the order they're in. The time complexity is big O of n, because magazine must have more letters than ransom mode. If there are fewer letters, we may immediately return false, as there are not enough letters to write our ransom mode. And we must go through each letter magazine once, to put the characters into our hash map. The space complexity is big O of n, so it tends to number of distinct characters in magazine. For this problem, we will only use lowercase letters, therefore our hash map will store at most 26 characters of the English alphabet. But because k has another bound of 26, this can be considered constant for all lengths of n and m, and therefore we have a constant space complexity. Let's turn this into code. Firstly, we'll need to create our hash map to store our letter piles. We'll iterate through each letter in magazine to populate magazine letters. I'm using the get or default method from the hash map to retrieve the current frequency of a given letter. If the letter is not in the hash map yet, then it will give us a value of 0. We can then update the frequency of the letter in hash map with the put method. The key will be our character, and its value will be the character we've retrieved plus 1. Once we've populated our hash map, we may then go over each letter in ransom mode. This time, we'll retrieve the frequency of the letter we need from our hash map. We'll use get or default again. If there is no such letter left in magazine, then we may return immediately. Otherwise, we update the frequency of that letter to be 1 less than it was, as if removing the letter from its pile. If we manage to go through all of ransom mode, we may return true. The time complexity is big O of n, as we iterate through magazines once.
哎呀，我操！太坑爹了，掉下去了，我操！去哪里了？嗯，没了。哈哈，吓傻了。怎么没了呢？这没意思。
whenever we remove a character. A hash map is a data structure with constant
拍一下。OK， 那么停了也没
and
声音。
therefore the size of our hash map. Our problem only allows us to use the 26 lowercase letters of the alphabet. In the worst case, k will be 26, which can be considered constant, giving us constant space. This has been your LeetCode video solution to problem 383, ransom mode. Thank you for watching.
OK， 看看这道题啊。方法千千万，直接写就好了。这个第一种最简单了吗？ 该怎么说？这有啥问题啊？我能看出来。MAGAZNA， 妈的！再看一下。OK。没问题。这没问题，就再做一个呗。这是啥呢？你稍微复杂点的吧。多久了呀？才4分钟，我的妈！都放这里干嘛？ 这弄完了往后出的话，我这么一说肯定就出了。这小问题啊。我用形容。哎呀，OK， 这样也算是圆满完成了。看看它的排名比较高的是怎么弄的？可以。这样子看这个翻译有点累，可以翻译一下。我是看懂了，但是说把那个放在26个字母里面去弄，因为它是固定的就去弄。这个有没有的问题，假如你能找到的话就可以，找不到就算了。哦，挺好。OK， 搞定了。那就这样吧。先把这个草放上去，这才有成就感。还有几分钟，可以把它上传，并且结束了。